This is Ms. Edwards, and today we're going to do review and preview problems 7-131 to 7-137 in the CCG book. 7-131 says, Tamika remembers that the diagonals of a rhombus are perpendicular to each other. Click on the lower right-hand corner of the graph to view in full screen mode. Question A says, graph ABCD. Is ABCD a rhombus? Show how you know. So when I look at rhombus ABCD or quadrilateral ABCD, I can tell that this is up 2 over 5. I can tell from point C to point B is over 2 up 5. I can tell from D to C up 2 over 5, and I can tell from D to A is up 5 over 2. So if I use the Pythagorean theorem, all of my hypotenuse would be the exact same length. So yes, it is a rhombus because all 4 sides are congruent. Find the equation of the lines on which the diagonals lie. That is, find the equation of line AC and BD. So if I first look at line AC and I connect these 2 points, to write the equation of line AC, I can tell that my y-intercept is 5, so I get y is equal to something x plus 5, and I can tell that I am going down 1, right 1, to get from one point to the next, so my slope is negative 1 over 1. When I look at line BD, and I connect line or point D to point B to form a line, I also want to look for my y-intercept, which in this case was 0. And then I want to look at my slope, and I'm going up 1 over 1. So my slope is 1 over 1x. My y-intercept is 0. Compare the slopes of line AC to BD. What do you notice? Well, I notice that they are negative 1 over 1 and 1 over 1, which tells me that they are opposite reciprocals of each other, which also tells me that my diagonals are perpendicular. Problem 7-132 says find another valid logical order for the statements for Penn's proof from problem 7-113. Explain how you know that changing the order the way you did does not affect the logic. So when we were looking at the proof from 113, if we look at our given statement, this must remain first no matter how we set up our proof. The last thing that we need to have is the statement that we were trying to prove. So 1 and 6 need to stay where they are. When we looked at the other statements, we should notice that statement 4 has to come after 2 and 3. Because logically, it doesn't make sense to say that A is equal to C if we don't have A is equal to B and then B is equal to C proven first. So 2, 3, and 5 can come in any order, and we just And that is because they discuss angles formed by parallel lines, but we need to make sure that statement 4 comes after statements 2 and 3. 7-133. Each of these number lines shows a segment in bold. Find the midpoint of the segment in bold. Note that the diagrams are not drawn to scale. So looking at A, I see that I have 3, 4, 5, 6, 7, 8, 9 if I label the numbers in between. To find what is in between 3 and 9, I could hop from both directions and notice that I end up with 6, which is the midpoint between 3 and 9. When I look at -1 and 7, I notice that those numbers are a little bit further apart. So the midpoint is the same as the average. So if I take -1 plus 7 and divide that by 2, I get the midpoint of 3. -15 and 2 are also a little bit further apart. So if I take -15 plus 2, divide that by 2, I get a midpoint of -6.5. 7-134 says examine the diagram below. Are the two triangles in this diagram similar? If they are, use a flowchart with justification or a two-column proof to prove similarity. If they are not similar, explain why not. Looking at these two triangles, the first thing I'm going to do is separate them into two smaller triangles. So I have triangle FGH, and then I have a larger triangle FIJ. So looking at these two triangles, I know that line segment FG is congruent to line segment GI, which must mean that G is a midpoint. I also know that line segment F is congruent to line segment HJ. So I am going to assume that I can prove these similar, and I'm going to start writing a flowchart. So I know I was given that the length of IG is congruent to line segment GF, and I'm going to state that that was given. I also was given that FH is congruent to HJ. So I always start with my given statements towards the top. I know that if I look at FI, knowing that FG is congruent to GI, I can say that 2 times FG would equal line segment FI. So my justification for that would be it is a dilation of 2. I also can then conclude that 2 times FH is equal to FJ. Again, I can justify that by saying it's a dilation of 2. I know that angle F is congruent to angle F, and I can prove that because it's a shared angle. So based upon that information, I can conclude that by side angle side similarity, triangle FGH is similar to triangle FIJ. Name all the pairs of congruent angles in the diagram. You can. I know that angle FGH is congruent to FIJ, and that's because we proved our two triangles similar, which means our angles would be congruent. I also can prove that or state that angle FHG is congruent to angle FJI because I proved those two triangles similar, which means their angles would be congruent. Are GH and IJ parallel? Explain how you know. Well, yes, they are parallel, and I know because these angles right here are corresponding angles, and if you have corresponding angles are congruent, you then know that the sides are parallel. This is also referred to as the triangle midsegment theorem. If GH is equal to 4x minus 3, and IJ is equal to 3x plus 14, find x. Well, I know that my larger triangle is 2 times my smaller, so 2 times 4x minus 3 should be equal to 3x, the base of my larger triangle. So when I distribute, I get 8x minus 6 equals 3x plus 14. Using my inverse operations, I get 5x minus 6 equals 14. Add my 6. 5x equals 20. X equals 4. I then can find the actual length of GH by plugging x back into my equation. So line segment GH is equal to 4 times 4 minus 3, 16 minus 3. Line segment GH is equal to 13 units. Consider triangle ABC with the vertices at the following points. Draw a triangle ABC on graph paper. What kind of triangle is ABC? Prove your results. So looking at this triangle, I think that it looks like a right triangle, but in order to prove that, I want to look at my slopes. So to find the slope of line AB, I rise 3 and I run 4. To find the slope of AC, I notice that I go down 8 over 6. Well, when I look at the slope of 3 over 4, so rising 3 over 4, compared to going down 8 over 6, I can see that my slopes are opposite reciprocals of each other. So I can then say that it is a right triangle because these slopes are perpendicular. Simply notating those slopes and writing this information here is enough to prove that. Looking at B, it says reflect ABCD across line segment AC. So when you reflect across, you could go inverse of what your slope was, down 3 over 4, and you could get your B prime, which is what they asked us for. So B prime is the ordered pair -2, 0. And then if we reflect point C over AC, it remains in the same place. So we have 2 adjacent right angles, which creates an isosceles triangle, and BC would be its shared side. 7.136, this problem is a checkpoint for solving with trigonometric ratios and the Pythagorean theorem. Compute the perimeter of the following shape. So remember, the perimeter is the distance around the outside. So in order to figure this out, I would draw a line down here. I would know that this piece of my rectangle is 5, which would leave 3 over here, which would equal 8. I then know that my height is also 5, so I could use the Pythagorean theorem. 3 squared plus 5 squared equals my hypotenuse squared. 9 plus 25 equals c squared. To know that the square root of 34 equals c squared, which means my side is approximately square root of 34. When I add 5 plus 3 plus the square root of 34 plus 5 plus 5 for the perimeter, I get my perimeter to be approximately 23.83 feet. Letter B says solve for x. So if I'm looking for x, I'm talking about my side that is opposite, my side that is adjacent. I remember that my trig function tangent is opposite over adjacent, so the tangent of 35 degrees is equal to x over 10. Use my inverse operations and multiply by 10 on both sides. 10 times the tangent of 35 degrees tells me that x is about 7 yards. Looking at letter C, it says solve for x. I'm looking at angle x. First thing I know is I'm going to need to use inverse trig. So my second button on my calculator, because I'm looking for an angle. I notice that 150 is across from my right angle, so that's my hypotenuse. My 60 is next to my angle, so that's my adjacent side. Cosine uses adjacent and hypotenuse, so the cosine of angle x is equal to 60 over 150. When you type this into your calculator using your second button, because you're looking for your angle measure, you get x is approximately 66.42 degrees. Letter D. Juanito is flying a kite at the park and realizes that all 500 feet of string are out. So if we are flying a kite and all the string is out, we know that the string is 500 feet long. Margie measures the angle of string with the ground using a clinometer and finds it to be 42 degrees. So the angle with the ground would be right here, 42 degrees. How high is the height above the ground? So across would be my opposite side. 500 would be my hypotenuse. The sine function uses opposite over hypotenuse. So when we use our inverse operations and we type this into our calculator, 5 times the sine of 42 is approximately 334.57 feet. 7137, must be, could be. So these problems are really, really important, and you're going to see them later for sure and on some really important items. Here are some more challenges from Mr. Quincy. For each description of a quadrilateral below, say what special type the quadrilateral must be and or what special type the quadrilateral could be. Look out, some descriptions may have no must-be statements, and some descriptions may have many could-be statements. So the first quadrilateral that they are describing, the quadrilateral has a pair of equal sides and a pair of parallel sides. If it has a pair of equal sides and a pair of parallel sides, it must be a trapezoid. However, it could also be an isosceles trapezoid, a parallelogram, a rhombus, rectangle, or even a square. So remember, for the could-bes, we would just need some more specific information to define those quadrilaterals. Looking at example B, it says the diagonals of my quadrilateral bisect each other, which tells me that it must be a parallelogram. But depending upon all the other information, it could also be a rhombus, a rectangle, or even a square.